So the first thing that we should discuss is why we would have a solar tracker in the first place. Well, if you watch the video that we're looking at now, you can see that the sun rises behind the church and it moves off towards the right side and the upper side of the screen. So in order to be able to track the sun, we need to be able to follow it not only as it moves from east to west, but also as it gradually increases in height, that is, as the sun increases to its highest point of travel in the sky. We're referring to the latitudes from the equator up until the North Pole or the equator down towards the South Pole. A lower latitude would be from the equator, approximately here, up until the southern tip of Florida, approximately here. A medium latitude would be somewhere between the lower tip of Florida up until the border of Canada. And a higher latitude would be from the lower part of Canada all the way up until the North Pole. The vertical solar tracker also has 1 degree of freedom, and it will move on an axis of rotation from east to west. Vertical solar trackers are better suited to higher latitudes. If we go around the back, we can see some of the control functions that allow us to control the solar panel. We've got a wind speed sensor or an anemometer, that is this item here. You can see the air would impact upon these small round cups and that would make them spin, and the speed that they spin at is proportional to the speed of the wind, so we can calculate the wind speed based on the revolutions per second of the anemometer. You can see that we've got 2 hydraulic rams. We've got the one where my mouse is now. Just zoom out slightly. And then we've got one on the opposite side. That is this one here. And these 2 rams control the movement of the solar tracker.